everyone please put your hands together for the fantastic Mike. Round of applause.
Great. Well, thank you very much for inviting me. It's been really actually interesting set of talks and lots of these different viewpoints and stuff are really useful. Anyway, what I'm going to talk about is essentially it's a new program. Well, I should introduce myself first. I'm a geophysicist at the University of Oxford, and I'm currently the head of the Department of Earth Sciences. But I'm also founder of a new program in Oxford called Oxford Earth, and I'll go on to explain what that is in a minute. But a lot of this goes back to, how do we look at equitable and sustainable access to resources that we need for achieving net zero. Let's see if I can just get my screen to move on here. And so many of you probably will have seen these sort of infographics, which just basically show what sort of technologies are needed for the energy transition and achieving net zero. And a lot of these are renewable energy. So that the technologies across the x-axis, if you like, and then the vertical axis are examples of different minerals and critical metals that are needed. And so in all of them, you can see we need a whole lot of steel. But things like copper are in huge demand. In fact, we need more copper in the next 25 to 30 years than we've ever consumed as human beings. And then you get into other less familiar but very important minerals like neodymium, praseodymium, used in wind turbines, that sort of thing. And so this is raises all sorts of interesting questions and demands. We can recycle a lot, and we can reuse and engage with the circular economy, but we are going to need a lot more exploration. And so some of the key challenges are, how do we supply these resources to a growing and energy-hungry population? How do we do this in an environmentally responsible way? And as we've heard about in a few talks already, how do we do this in an equitable way? And how do we manage a quickly changing geopolitical landscape? And that seems to be changing more and more quickly every day right now. And so to address some of these questions, we've established Oxford Earth. Earth stands for Equitable Access to Sustainable Resources for Thriving Habitat. And it's really like, there's a lot of discussion about what it takes to get to net zero and how we can manufacture low carbon equipment, technology, that sort of thing. But we seldom talk about where are we actually going to resource, where are we going to get the raw resources needed for this. So this new program is a cross-departmental institute. It covers 9 departments across 2 divisions. At any other university, that would be 2 faculties. And it's looking at how do we sustainably resource, how do we manage waste management in a whole range of technologies and industries, which I'll come back to. But it's an inherently a cross-disciplinary collaboratory approach. So we're looking at ethics, policy, biology, chemistry, law, engineering, economics, earth sciences. And a key part of it is really stakeholder engagement. How do we engage well with industry, policymakers, regulators, NGOs, and probably most importantly, the public. And so there's different themes that we're looking at in the program. A key one is critical metals. How do we do a better job of finding critical metals with conventional technology? But what are some of the more disruptive technologies that we can use to find things like lithium, rare earth elements? Critical gases, hydrogen. There's a lot of talk about hydrogen. You don't hear so much about helium, but helium is also in very, very short demand right now. A very interesting area, which I'll say a bit more about later, is how can we use microbes in metal recovery and bioremediation, that sort of thing. How do we look at environmental impact, remediation of old mine sites, for example? How do we engage with a circular economy, repurposing, recycling? And then, as I said earlier, history and ethics and social license are a really important component of this. And then finally, policy and regulation. So I'm only going to talk really about the top 3 of them to give you an idea of some of the projects that are that are underway in Oxford Earth. The first is this idea of using microbes in mineral bio production. So this is a collaboration between earth sciences and engineering. And Julie Cosmides, who's from my department, wrote a very interesting opinion piece really on will tomorrow's mineral materials be grown? And what's kind of key to this is, can we use mineral forming bacteria to recover mineral resources from waste? Or can we use biominerals to advance materials for technological applications? So, for example, Julie looks at using industrial waste to grow or manufacture sulfur lithium batteries. And so there's a lot of work on, the micro community is diverse. How do you manipulate the genes and the DNA to, preferentially extract the minerals for the application that you would like? And working in synthetic biology is a huge emerging field right now. And one of the things that we're looking at is, how do you adapt these metal accumulating bacteria to thrive in hot geothermal fluids? Reason for that is that geothermal fluids often contain a huge amount of critical metals depending on the tectonic setting. And there's, robotic platforms now for doing this in a very large scale. And this is something that Harrison Steel is really pioneering here at Oxford. I always think Harrison Steel is one of a great name for working in the mineral industry. Then another theme that's very a lot of research is going on here in Oxford is looking at hydrogen, and the primary emphasis is on natural hydrogen and really sort of better understanding how natural hydrogen is produced, what it takes to have a reservoir of natural hydrogen, so we can look at things like water rock interactions or serpentinization or radiolytic sources. And it covers a whole range, basically the tectonic pantheon of terrains that we can look at around the world. And Chris Ballantyne and Mike Daly are really leading this, and they have a Nature Reviews paper just coming out, which really shows some of the exemplar places to look for this. And it also feeds into this very interesting conversation about, the rainbow of colors of hydrogen. And, I think gray and blue are a lot less appealing for a large number of reasons, but, it's essentially green versus natural, or what some people call gold hydrogen. The cost of green hydrogen is going to get cheaper as renewable energy. This is the idea that you form hydrogen through electrolysis, and you use renewable resources, so zero carbon energy to produce that. And this is going to get cheaper and cheaper, and will eventually become cost effective. But the cost and carbon footprint of natural hydrogen right now make it a very highly competitive source. But it's the key challenge is finding these reserves and ensuring that we've got the gas quality and hydrogen purity that we need. And then I'll just finally talk about this idea of co-recovery of metals and geothermal energy, which is getting a lot of press right now. One of my colleagues, Professor John Blundy, wrote a paper recently that was picked up by the Financial Times, the title being "The Next Critical Mineral Soup Could Be Volcanic Soup," or "Mineral Source Could Be Volcanic Soup." And again, this is a collaboration with chemistry. So if we conventionally, let's say, look at copper, we'll look for a mine like this. This is Cerro Colorado in Chile. This was once an active volcano many, many millions of years ago, and it's cooled. And through exploration, we've found, people find these copper deposits. They dig a huge hole in the ground. 99% of the rock that's excavated is thrown away, and then it's processed, and copper is produced. And one of the things we're looking at really is, rather than trying to find an old extinct volcano, can we go to a active volcano? So here's Mount Etna in Sicily. And this is on the left is the gas flux coming out of Mount Etna every day. And so there's a whole bunch of the periodic table here is being emitted out the smokestack of Mount Etna, but I'll draw your attention to copper, seeing that's what we've been talking about. Over 10,000 kilograms of copper are emitted from Mount Etna each day. And we know that if that much has been emitted, there must be more trapped in condensed fluid underground. And there's about 2,000 of these sort of degassing volcanoes worldwide. And finding one of these volcanoes is a lot easier than finding the next copper mine. And the key question is, can this be accessed economically? And just to show you, it's not such a ridiculous idea. It's not a volcano, but it's a 89,000-year-old granite heat source called Kokonda in northern Japan. And here they're drilling deep to try and find supercritical geothermal sites. And in 1995, they drilled nearly 4 kilometers deep, got temperatures of 510 degrees. And the brines, the salty liquids that were recovered in this from this borehole were incredibly rich in minerals. So again, just looking at the left here is the parts of the periodic table, but you can see huge amounts of gold, copper, zinc. And this is interesting for especially geothermal producers because right now geothermal energy is very, from an economic point of view, doesn't compete well with diesel, for example. But if you can add an extra revenue stream through co-recovery of metals, all of a sudden, in fact, the most valuable thing here in Kakonda would be metal recovery. And very often geothermal companies try to stop scale and metals being brought to the surface by flushing acids down boreholes. And so what we're looking at are ways we can actually take advantage of these metals. And so I'll just wrap up with showing you an example of a project that's been funded by the Oxford Martin School. It's looking at the island of Montserrat. Montserrat was devastated by Hurricane Hugo in the late 80s. And then from the mid 90s until recently, there's been long sustained eruption of Seafarer Hills, shown here on the left. And this is an island that's gone from nearly achieving independence from the UK to a diaspora of nearly 10,000 people leaving the island. And they really desperately and passionately would like to become more self-sustaining, certainly in terms of energy. They rely on diesel, which is intermittent right now and quite expensive. And so we brought together a program that brings together scientists, economists, people looking at circular economy, history, and reflections of ethics, and exploring really the interconnected issues across the themes of resources, rights, risk, and resilience. And there's different work packages. I'm sort of leading the, how do we optimize exploration for the geothermal and mineral endowment in this area. The second one is looking at how we actually get it out, what chemistry and engineering is needed. The third is looking at the economic and regulatory framework. And the fourth is equitable extraction and social license. And so it's been an amazing project in collaborating. I mean, the deployments have been exciting, sometimes using helicopters to go into the exclusion zones. We work really closely with the Montserrat Volcano Observatory. In fact, there's no way we could do this work without that collaboration. We also engaged very closely with the National Trust. One of our postdoctoral researchers from history has spent 6 months on the island doing ethnographic studies. There's a picture of being involved in cleanup of the beaches at some point. We're engaged with the government, both the British FCDO government, but also the Premier. This is the newly elected Premier Reuben Mead, who's coming to visit us in a few weeks' time. We've also done a lot of outreach talking to schools and children about, geothermal energy, what it's like living with a volcano, that sort of thing. So we're only sort of a year and a half into the project, but I'm expecting some really exciting results by the end. So really to wrap up, I think what's exciting about Oxford Earth is that Earth Sciences is really, leading the way and showing how we can provide solutions to some of the challenges we have ahead of us. And this is a much more positive message to students in that, humans are innovative, and there are interesting ways we can look at addressing net zero and the energy transition. I think working with industry is crucial. It doesn't neglect, or negate the need for an acute need to reduce, reuse, and recycle. I think the co-recovery of geothermal energy and critical metals is a really exciting area right now. Equally, hydrogen and helium exploration, bioremediation, biomining, which I talked to you about also. We need elements of carbon capture and storage, obviously. But I think, as I said earlier, what's kind of crucial in all this is social license. And some of the previous talks, mentioned things about, it's fine if it's mined somewhere else, but it's very difficult to get, something done near to home. And I think this is actually really an important issue that needs to be addressed. And so, an important objective in all of this is to ensure that achieving net zero in one part of the world does not lead to deleterious consequences in another part of the world. And so just as a conclusion, climate change is one of our most pressing societal issues right now, and reducing our dependency on fossil fuels is a key challenge. Humans are great innovators, and now more than ever, we are seeking innovations in a wide range of areas. And the field of earth sciences is really providing some of these solutions, but interdisciplinary collaboration is key to all of this. So with that, say thank you and take any questions.
Brilliant. Thank you so much, Mike. That was absolutely fantastic. Round of applause, everybody. Mike, I mean, kind of getting a glimpse into some of the projects that are going on within the group is great. I mean, anytime you talk about drilling into a volcano fills, I think, everybody's hearts with both glee and slight fear, shall we say, with regards to that. In terms of bringing together, or I guess convening or encouraging all those different disciplines to collaborate with one another. That's easier said than done. Any hints and tips as to how you get that variety of disciplines to collaborate?
Yeah, well, it's just what, Kombata said previously too, being aware of each other's sensitivities and differences in these sort of more complex collaborations I've had. You generally spend quite a bit of time just trying to understand each other's language. But if there's a willingness on both parts, it happens and it can be very rewarding. For example, have worked for 25 years in Ethiopia, actually, first of all, just studying why Africa is rifting. And my collaborations with collaborators at the University of Addis Ababa and the Eritrean Institute of Technology have been wonderful. I mean, and I've made long-lasting friends through this. So, and it wouldn't work without that collaboration. What I've found interesting in Oxford actually is just how um, enthusiastic and people are. They really do want to collaborate on these topics. I had absolutely no problems bringing people to this program. But yeah, you do have to really understand. We had with the social scientists, we had sort of a bit of a surprise at the beginning where we thought we'd sort of done everything properly, and they just said, "Well, you didn't ask us what we needed for our field work." And our field work isn't going out for a week, putting out instruments. It's like we need to spend months with a population. And that was a big sort of, okay, well, I hadn't quite realized that. Um, so it's a bit of a long-winded answer, but yeah, that's
No, I think it's great because it's almost the kind of learning from the surprises
mhm.
that one another have. So, for example, as you mentioned on the social science side, actually, it takes years to often develop the trust and the relationships so they can even begin to kind of almost start collecting the data sets. Whereas from the physical science perspective, well, I mean, the rocks don't speak back, but actually, we use sort of very different techniques. Have you had any other surprises so far?
Well, an interesting one. I wouldn't say it was a surprise, but I've noticed this before working with the Montserrat Volcano Observatory. The worst thing you can do is to sort of come in and say, look, I'm an expert in this area. Help us do all this experiment, this work. And there was a fair level of, I wouldn't say distrust, but I wouldn't say that we were welcomed with open arms. I mean, I think the volcano observatory has got a bit of fatigue with scientists coming and saying, I want to study this volcano because it's active. And they're meanwhile trying to manage the hazard and the risk on a day-to-day basis. And in some ways, it's like, and again, it was just like, look, everything we're doing will feed in, will help you with and it's mutual respect, right? It's like, what they've been doing is absolutely phenomenal on a shoestring budget, and recognizing that. And so yeah, that wasn't surprising, but yeah, it took certainly a little while to get over that sort of natural distrust, or as Kambada said, people come in, do all this exciting research, leave, and next thing you know, a paper is published where they're not even, they may be acknowledged. So whereas we've right from the beginning involved those scientists in our publications. So.
Yeah, absolutely. It's so important. And one final question that's actually just come in that's then about working with industry. So you mentioned industry collaborations, and sometimes the driver or the kind of the outputs that industry wants are perhaps different compared to, I don't know, say the observatory or Montserrat, or from an academic perspective. Have you got any thoughts with regards to how do you bring those together?
Yeah, I mean, I'm sure many of you on this in this meeting are more of experts at this than me. I mean, what we're trying to do in the autumn, we'll bring together a whole range of stakeholders to discuss, these issues precisely. What are the concerns, and so it'll be a sort of a 2-day workshop where, I mean, the vision is to get, as extreme as Just Stop Oil and Shell in the same room, and a big mining company and a big environmental NGO, and have just really robust conversations to try and understand where each other is coming from. So actually, if any of you'd be like to stay in touch or get involved in this, please email me. But yeah, I think we're in early days of that process right now.
Brilliant. That's absolutely fantastic. Well, with that, thank you very, very much, Mike. Round of applause.
Thanks for the
Fantastic.
invitation.